Because it's a number. Right. It's not divided by 5. It's 5 divided by now. Because it's P times all that glue, we have the P row is 5. Okay. Sorry. Okay, I'm taping. Here we go. Thank you for being quiet. Gentlemen and ladies. I don't know. I don't know. It is sad that Chloe looks like she's on her phone with a computer. You know, it's like a fake face or something. I think so. Like you're playing. Well, like if you're addicted to something, it's like I won't do a real one. I'll do something fake. Right? Okay, here we go. Gentlemen, quiet. Everyone's quiet. Here we go. So Jace, I need 15 minutes of no time. So just okay. So here's the deal. Yesterday when we did our problems that were real problems, we did a little bit of economics, and today we're yeah, especially because I'm taping, so you're making it hard for people who are listening at home because they have to wait for you guys. So we're doing Half-Life. If you have taken honors chem, if you've taken physics, even if you took algebra 2 trig, you saw this, and I'm gonna just need to talk without. So I'm gonna stop the taping. I seriously just need to get through this without stopping every 2 seconds. So if it's, I'm not asking, if you want to just move over because it's so hard to stop, that will be fine with me. Just move over. Okay. So Half-Life, here's the bottom line in science. It's either in real life, every substance in the world is doing one of two things. It is either growing or it is decaying. That there is no stasis in the universe, right? Some things feel like they could last forever, like a diamond, but it eventually, with enough time, will decay, right? It goes away. You as people are either growing, and then once you stop growing, sadly, you start decaying. That's just all there is to it. So what scientists do is they go ahead and measure how long things take to get to their halfway point. So say you had 100 pounds of a diamond, you would want to know how long would it take, how many millennia, because it would take probably thousands of years till you get, why does it keep doing that? How long until you get to half of that amount? And that's called half-life, right? And these are measurements that scientists have taken because we can use them for things. Sometimes things decaying is just what it is. So every organic thing in the world, anything that's made of a plant or an animal, has a thing called carbon-14 in it. You do, I do, all of us. The minute we die, that carbon-14 starts falling apart. And that's how they see how old things are, is they say, you're supposed to have this much carbon-14, but your bones have been sitting in the backyard for a decade where you got killed and buried back there. And now, I know it's sad, but it happens. And now you only have this much. They can go ahead and say, that's how long you've been gone, right? They can date how long things happen. And so sometimes half-life it's not great, but it doesn't hurt you. Sometimes things decay really, really fast. Like there are some substances that are only around for seconds. And here's what's interesting. When they decay, some things give off energy. And that can be really good. If you put it in a nuclear reactor and you make it safe, you get nuclear energy. That's what's happening. You're putting plutonium in there. It's decaying. It's giving off energy. We harness it. Yay. But if you hold plutonium in your hand while it's decaying, it is radioactive, and that's how Marie Curie died. Is that her gums bled and her teeth fell out and she died because she had radiation poisoning. So some things that decay we want to stay away from, and we want to know what their half-life is because they will kill us. And some things just decay because they just decay. So half-life is not always bad. Everything has a half-life, but sometimes it can be dangerous. So what we're going to do is we're going to figure out how old or how much stuff we have using the idea of half-lives. It takes the formula we've been using, it changes it a tiny bit. On the test, I will give you the half-life formula. That's not what I'm going to be testing on. You need to know how to use it. So are you ready? We're going to write down this formula. You can write it later then on your whiteboard desk and then write it on your paper tonight. That is awesome. You don't need to memorize it, but you do need to know how to use it. Are you ready? So we have been doing a formula that looks like this. A equals P E to the RT. And half-life switches out a few things, just a few tiny things it switches out. It says, hey, E is 2.7 blah, blah, blah. It makes things bigger. We want to make things smaller, so instead of using that E, we're going to use a 1/2. So our formula is going to have 1/2 in it instead of E. It will still have an amount that we start with. It will still have an amount that we end with, right? But because we're making it littler every time with that 1/2, we don't use rate quite the same way. We still are going to have T up here, but here's the one new thing. We are going to add in a new variable. And the new variable, instead of rate, is this guy, and he has a little 1/2 here. It is not mathematical. That 1/2 is not math. It's like me putting a little asterisk next to your name to say, that just means half-life. So here's what we know of our formula. A will always be our ending amount. And tonight, it will always be the smaller of the amounts, right? Because we are having things go away. They're decaying. P will always be the starting amount. And tonight, it will always be the bigger of the number. Does that always happen? No. If you have zombies, you get more and more zombies. But with half-life, it's stuff going away. The T is always going to be time. But this is the important guy. We don't have a rate anymore. What we have is a half-life. And that means some scientist guy figured it out.
But we're for the T with the whatever substrate, we're literally carbon 14 half-life is.
He's like the rate.
So we're just putting that number, whatever that is.
Sometimes we can even find it. Because he's just, you know what I wish? I wish the variable had been this.
Yeah, hello.
For H for half-life. Wouldn't that be nicer? Yeah. So, now for some of my friends, and I'm looking at you, Owen F. This one, on E, I don't think you take physics, do you?
I did not.
You did not. So, if you are taking physics, and I know you are right now, you're like, but that's not what the formula looks like. Here's what they do in physics. You don't have to worry about this. I'm sticking with the same variables because they make me happy. In physics, you know what they say in here? They call this N0. That means starting place amount. And N, which is ending place amount. Am I happy with A and P personally? Yeah, because we've been using it this whole time, right? But if you're taking physics and you're like, that doesn't look like a formula. And now you should be able to say, oh yes, that looks like a formula. Okay? So, is it the exact thing we've been doing? Yes. Is it finding 4 things? Yes. Will they give us 3 out of the 4? Yes. Will we move stuff around to figure it? Yes. Did you leave your phone? Yes. Yeah. Okay. So here, can you see how I did that? Okay, you guys ready? Here we go. First one. Okay. So we're gonna write it on the whiteboard desk. Figure out how to do this. So Hannah of course she's not here today, is a radioactive substance with a half-life of 75 days. It glows rainbow. Look how pretty I made that. But it will kill you. If you start with 100 grams, how much will be left after 40 days? Are we ready? So for me, I do it the way I always do it. But remember, instead of having a rate now, we have a half-life. We have a half-life. And it works fine. It really does. It's really not scary. So guess what? We're starting with 100 grams of this stuff.
Oh, that was you. I was gonna say, how the hell?
We are left, so our time is 40 days. Our half-life is 75, right? And we want to know what's left. Now, before we start this problem, obviously it's going to take 75 days for half of it to go away. We're not going 75 days. So we should get a number somewhere between 100 and 50, somewhere between 50 and 100. If we get more than 100, that means that stuff's growing in our pocket. That's creepy and weird. We don't want that to happen. And if we get something less than 50, that's wrong too, because it says 75 days. So you ready to plug it into our calculator? It's all plug and play. Here we go. A equals 100 1/2 to the 40 over 75. I am going to walk you through it with your calculator. Have your calculator out, ready to go. Everybody ready? I'm going to give you a few hints. Hint number 1. Please make this 0.5. Hint number 2. Please pull up parentheses around this guy. I am always worried that when I raise it in my little caret, that it will go 40 and then divide the whole thing by 75. It worries me. So I am careful with my parentheses. Are we ready? Get your calculator because I want to make sure everyone gets the same answer. Ready? 0.5 to the parentheses 40 divided by 75 equals multiplied by 100. So, Sean, what'd you get? So, in other words, do the problem, okay? You just get a calculator, just follow along. Like that. Like I'm kind of waiting for you to get it. There's a ton right next to you. See, that's what's so cool about this process. What? You got 69 and that would be correct.
Can you show me how we do that again?
Okay, you ready? 0.5 to that, that's the caret. Parentheses. 40 divided by 75. Enter. Times by 100. Times by 100.
69.
You good? Okay. Here we go. Let's try the next one. Okay, this was the highlight of my night, and you know what? It's been so disappointing. The best I got was Daniel Lewis gave me like a half smile when I showed this next part. So here we go. You got Benium. It's a substance that makes you cool and laid back, has a half-life, blah, 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 blah. How do you get Benium? How do you do it? I will show you how you get it. You walk up to him, you have a sharp knife, and you take a piece of him off.
What?
See?
Whoa.
That's it. Thank you. Thank you. I appreciate this one. Like, I worked really hard to make his little arm be detachable. There. Now his little
I
arm.
don't think you passed the second test.
I don't. But you know what? There we go. Are we ready? Let's set it up. A, P, T, T, half-life. Okay. We know how much you're starting with. 80 grams of this stuff. Oh, what the hell happened there? Right? 80 grams. We know what you're going to end with. 8. We know what the half-life is. 45. We don't know this guy. Now you're going to set it up in your equation, and I'm going to tell you this. You know how to do this problem. When you have a variable that is in your exponent, you need to use ln on each side. Now here's the bummer. We don't have e, so nothing's going to cancel. Set it up. You know how to do this math, you guys. You totally do. So set it up, and then we'll do it in a second.
Can we multiply the 8?
Divide.
Can we multiply the 80 by the 1/2? The 1/2 is 11.
Good question. We isolate the exponent. Great question. So Jordan just reminded us we isolate the exponent. So watch this. T over 45. Check this out. Isolate this guy. Get that guy alone. Get him alone first. How do we bring something down on both sides? No, because on both sides. Yeah. About 150 days? No? Well, we do know how to do it. We've done this so much. So this is awesome. I'm going to get it.
I mean, I know how to do it. I just working right here.
So we need to bring this down.
I think it's just because it's different.
Yeah,
And then this is cross. That's where I learned.
So we're just going back. Okay, so what we're going to do, divide both sides, right?
So anyways.
Love that.
But in this case, we just use ln, which is it's just
So thinking like.
ln is just log. But we just use ln. You just want the same thing.
Crazy. What?
I mean, I divided by
149?
and then that's
No, together? Everyone's got it. No one needs it.
That's the way to play.
Last one.
Wait, I don't know how to get from where I'm at right now.
Okay. So, here we go. I'll blow through it.
I got that. And then from here, because you want to get
I need to bring that down. The only way I know how to bring it down, ln. We used to get to cancel these, but we can't because it's not an E. Are you good? This has now come down. How do I get rid of that 45? You are on fire. Nice, nice, nice. Okay, last one, best one. I feel like I'm losing you guys. Here we go. I made it a dinosaur, but it really should be a mastodon bone or a saber-toothed tiger. Carbon dating only works for about 50,000 years. Anything less than that, they have to use your strata, meaning where they found the bone in the rocks. They date the rock. So if you ever find a dinosaur bone and you just throw it, it's really hard to date that bone. So let's say it's a saber-toothed tiger and you find the bone. Here we go. This one is a little bit tricky. So I'm going to have you move just one seat over because I need to go through this problem. It's tricky and I need to not talk over you. Okay. So here's what we got. A, P, T, and T to the 1/2. You find your bone. You take it to Mr. Taylor, and he's going to tell you, wow, that bone only has 25% of the carbon it's supposed to have in there. Well, the problem is he just shaved some of it off. So in math, we're allowed to do this. If we don't actually know how heavy the bone is, we can fake it, Justin, but I'm not going to answer your question anymore today, right? Okay. We can fake it as long as we fake it realistically. Watch what I mean by that. Let's pretend the bone was 100 pounds. And Mr. Taylor just said, oh my God, it only has 25% of the carbon it's supposed to have. If it's supposed to have 100, what would that number be? 0.25, does that, or 25, does that make sense? Because you only have 25% of it. What if I told you, oh my gosh, you have 45% of it? If that's 100, what would that be? 45. You are allowed to do that, and I'm going to show you because the first step will be, when we divide, it turns into that percent. Does that make sense? Watch what happens here. So here's what we know. 0.25 here, 25 here. My carbon decay is 5730. That's real. I looked this up. This is real. You want to see how old is this damn bone. So let's do this problem. So here we go. We're going to say 25 equals 100.5 to the T over 5730. What's the very first thing we're going to do? Divide by 100. And what is 25 divided by 100? Yeah. That's why we're allowed to do that little shortcutting thing. If that had been 70, it would have been 70 over 100. You see what I'm saying? So it's not really cheating. It's just a really nice way when you don't know the actual amount, but you know the percent. So you guys can do this one. It's exactly what we did on the last one. Do the math now. You guys are good at this. ln both sides. Move it over. Times by 5730. Try it. Roll. Okay, fine. Sorry, it was such a bad video. Not bad.